Building infrastructure on the moon. Earth gets a new quasi-satellite. A black hole has wandered away from the center of its galaxy. And a tour through star-forming nebulae thanks to Gaia. And on Space Bites Plus, China's new neutrino detector comes online. All this and more in this week's Space Bites. It's been a while since we've heard anything from Blue Origin. Is that still a thing? Obviously they're working on their new Glenn rocket. They're working on New Shepard. I think there was a new flight of New Shepard, probably. But they are working on a project that I find really interesting, and it's called Blue Alchemist. And the goal here is to develop a in situ resource utilization factory that could be deployed onto the moon. And so then it could scoop up lunar regolith and then use a molten regolith electrolysis reactor to turn electrical current powered by solar energy into a variety of byproducts. So the system would scoop up lunar regolith from the surface, use this molten regolith electrolysis reactor, split the regolith into its component parts, different kinds of silicon, metals, as well as oxygen as a byproduct. And then it can gather all of those materials together and make them available for other things. 3D printers, you could use the oxygen for the astronauts to be able to breathe, other things like that. And so this is still just in the original design phase. But this week, Blue Origin announced that the underlying concept has passed their critical design phase. That's where they feel pretty confident that big picture, this is going to work. And then they're going to move forward and actually develop a prototype and test this in a simulated lunar environment sometime in 2026. Well, people want to know my opinions about space mining. Will we mine the moon? Will we mine asteroids and bring the resources back to Earth? And it's just too expensive. There's no financial reason to do that. But if you're going to set up a base on the moon and you're going to need resources, it makes a ton of sense to build those locally out of the local lunar regolith. Now, I've got a much longer story about this from Matt Williams that goes into the details. Earth has only one moon, the moon. And, despite people are going to try and give you trick questions about how many moons the Earth has, the answer is one. But the Earth has a collection of other objects that will spend some time in our general vicinity from time to time. Now, there's a bunch of different kinds of objects. There's quasi-moons, there's horseshoe librators, and other objects that can spend time near the Earth. And it's always interesting when one of these new objects is discovered. And you might remember about a year ago, we were talking about 2024 PT5, and it hung out for a little over a month and then drifted away again. And now there's a new object called Arjuna 2025 PN7. And this was discovered in 2025. And it joins about a half dozen other objects that are in the vicinity of the Earth, that their orbit around the sun matches the Earth's orbit around the sun. And then you get these additional gravitational interactions with the Earth. Now, these things aren't just in orbit around the Earth, although they can sometimes do a few orbits around the Earth, but it's more this complex gravitational dance with the Earth always remaining kind of in our vicinity. And it's expected that Arjuna 2025 PN7 is going to remain in this orbit for about 128 years. And then it's just going to drift away and become a regular near-Earth asteroid crossing our orbit from time to time. And we've got more information about this from Evan Goff on Universe Today. Whenever I talk about the first exoplanets ever found, I get a bunch of ahem actuallys in the comments saying that the first exoplanets ever found were actually orbiting around a pulsar. And this is true. The first exoplanets ever discovered were found around a pulsar in 1992. And then that beats by 3 years the first planet orbiting around a sun-like star, which was Pegasi 51b. It's easier to find planets around pulsars because of this very predictable radio signal that is coming off the pulsar. And so if there's some kind of change, if it's oscillating, you can detect the presence of the planets. And now astronomers have found what seems to be a very large, almost hot Jupiter-like planet orbiting around a pulsar. But everything is super weird about this system. So the pulsar is classified as a black widow pulsar. And this is an example of a system where you've got a pulsar, a type of neutron star, a dead star that is orbiting around a more main sequence star. But the pulsar is pulling material away from its companion star and adding it to its own mass. And this creates a lot of additional energy in the system. And so new observations of this pulsar, designated PSR J2322-2650, is that it has a hot Jupiter-like planet orbiting around it. It is in the kind of hot Jupiter size. One side of it is about 2000 Celsius, and it's tidally locked to the star. But what makes it strange is that its atmosphere is almost pure carbon. And this is not something that you would see in a typical exoplanet. You might see traces of carbon here on Earth. Our atmosphere has traces of carbon dioxide in the atmosphere, but it is mostly oxygen and nitrogen. But this planet is all carbon. And this has led astronomers to think that, in fact, this was once a star that was orbiting another even larger star. And then the first star detonated as a supernova, left behind a neutron star, a pulsar. And then the pulsar started to feed on this second star, stripping away all of its outer layers down to the core. And so what we're seeing is this version of the core of the star that is orbiting around the pulsar every few hours. It's a bizarre system, and yet just shows you all of the strange combinations that can happen out there in the universe. We've got a story about this from Andy Thomaswick. Astronomers know of two types of black holes. There are the stellar mass black holes. They're created when a star with more than about 20 times the mass of the sun reaches the end of its life, explodes as a supernova, and you get this dense remnant, and then it can build up material over time. And then the other kind of black holes that we see are the supermassive black holes, the ones with millions, sometimes even billions of times the mass of the sun at the centers of galaxies. But there's a third classification of black holes that astronomers are starting to find more and more examples of, the intermediate mass black holes. These are black holes with thousands to hundreds of thousands of times the mass of the sun. And they're being found in dwarf galaxies, which kind of makes sense. You've got a smaller version of a galaxy, it's got a smaller version of a black hole. And you typically can't find these black holes until they're interacting with their environment in some way, that they are active and they are releasing radiation, releasing jets of material, and we can use that to pinpoint the position of the black hole. And normally, these black holes are dead center in the middle of their galaxy. But now astronomers have found an example where there is an intermediate mass black hole with about 300,000 times the mass of the sun, but it is offset from the center of its galaxy by over 3,000 light years. And so the question is, how did it get like this? One possibility is that the black hole formed at the center of this dwarf galaxy the way they normally do, and then it went through some kind of merger, tidal interaction with a larger galaxy, some other galaxy, that caused it to drift out of its original position. But another possibility is that it just formed the way all supermassive black holes form, which is still a bit of a mystery, but formed, building up more material, growing gas, but it found itself in a place that had higher quantities of the kinds of material that black holes feed on, and so it formed there and didn't form at the center of the galaxy. So it's an ongoing mystery. And actually, this is just one example of a dwarf galaxy that has been found with an active galactic nuclei. And the evidence seems to be growing that there are many of them. More than half of the black holes in dwarf galaxies are not at the perfect center. So it's an unfolding mystery and could give us some interesting answers about the growth and formation of black holes. We've got a story about this from Evan Goff on Universe Today. Lava tubes are some of the most interesting places that we could search on the surface of the moon and Mars. And this is because they are these natural caves that were formed. At some point in the past, there was a giant volcanic eruption and there was lava flowing under the surface. It emptied out the tube, and now you've got this gigantic empty tube on the moon and Mars. And this is a place where you could learn about the ancient history, look back through the geologic layers of the world. But also, you've got a place that is protected from radiation, from micrometeorite bombardments. The temperature remains constant. They're really fascinating places both to understand, but also a place to explore a world like this very safely. You imagine when you've got this collapsed skylight on some lava tube where the ground could be hundreds of meters down. How do you get down in there and actually start to explore it? So European engineers are testing a new trio of robots that might be able to work together as a team to be able to explore lava tubes on the moon. So the big one is called Sherpa TT, and it is a hybrid wheeled and legged rover. And what it'll do is roll around the edge of a lava tube, get itself right to the edge, and then it will deploy a rope down into the lava tube. It'll also drop a camera down into the tube to get a quick snapshot of what's down in there. Then it will deploy a rappelling rover called Coyote 3. And this will be reeled down into the lava tube, down to the bottom, or can then drive around inside the lava tube, exploring the inside. And then there will be another partner robot called Luvmi X, which will help map the terrain around the entrance to the lava tube. And so what's cool is that the Europeans are actually testing out this trio of rovers in the Canary Islands right now. There are collapsed skylights in these lava tubes. The islands are very volcanic, and so you have very similar conditions, and it's like the perfect terrain to test out this idea. And so you can imagine some time where these rovers go together to the surface of the moon and then explore the inside of a lava tube. We've got a story about this from Evan Goff. Every week, we do a vote on our channel where you tell us what you thought was the best space news story of the week. And the winner this week, by a landslide, was that NASA announced a potential biosignature on Mars. And obviously, this is one of the hugest pieces of news, if it turns out to be true. So thank you, everybody who voted. Now we're going to put the vote for this week's episode into the post tab on our YouTube channel. Of course, the best chance to see these votes is to subscribe to the channel, click on the notifications bell, and then just vote every time you see one. And that will train the algorithm to show it to you. One of the big stories that we are continuing to cover are little red dots. These were strange compact objects discovered by James Webb early on in its operations. And the exact nature of these continues to puzzle astronomers. You've got what seems to be a collection of stars compressed into a extremely tiny region of space. So imagine the solar system here out to, say, a light year across, and we've got one star in this region, right? The sun, and parts of the Oort cloud. With these little red dots, if our observations are right, you would have hundreds of thousands of stars in the same volume of space. And so astronomers are trying to understand what sets those conditions. Why are you going to have all those stars in such a small region of space? But one alternative way that astronomers are thinking about this is that it is not a collection of stars seen very close together, but actually that there is a supermassive black hole that is at the heart of this region that is then surrounded by enough gas and dust and an accretion disk, and it has this envelope of gas around the black hole that is then shining in a way that makes it appear to be the same kind of light as a whole bunch of regular visible stars collected together into this small area. So the astronomers who are proposing this version of the idea are going to be getting more time on James Webb to try and examine some of the best examples of these little red dots to confirm it. We've got a story about this from Mark Thompson. And now it's time for some cool images. And this is not one picture. This is a video that was created thanks to data from ESA's Gaia mission. And of course, we have been mourning the end of the Gaia mission earlier this year, but the data is still coming out and researchers are continuing to use it to make all kinds of scientific discoveries. And so this is a fly-through of 4 star-forming regions in the Milky Way. The first up is the Gum Nebula, which is about 1,400 light years away, and it contains the Vela supernova remnant and a bunch of cometary globules. Now, these aren't actually comets. These are newly forming stars that are surrounded by gas and dust, and the radiation is causing these comet-like tails. There's the North American Nebula, and it really looks like its namesake, even when you take pictures of it with a small telescope. But the Central American part is known as the Cygnus Wall, and is a concentration of star-forming region. There's the California Nebula, and again, it looks like its name. And in this case, you've got a star-forming region about 1,000 light years away, and there's an extremely hot star called Persei, and its radiation pressure is pushing away from the star, causing this material to bunch up. And then finally, there's the Orion Eridanus superbubble, which is a massive cavity carved out by multiple supernovae. So just really cool pictures. Thanks to Gaia. And we've got a story about this from Evan Goff. I hope you enjoyed all of those space stories, but if you want one more, we've got another version of this episode of Space Bites over on Patreon, which we call Space Bites Plus. And we've got one bonus story for you, which is all about the new neutrino observatory that has been opened up and has now begun operations in China. And you can go and watch that episode of Space Bites. It's completely free and there's no ads. And I'll put a link in the show notes so you can go and watch it there. If you still want more news, we are covering dozens of stories over on Universe Today. For example, the first dark matter subhalo found in the Milky Way, Saturn's opposition in 2025 and its rings are edge on, and how the bright comet Swan could perform a surprise visit in October. So if you want those additional stories and many more, I am working on my weekly email newsletter, which I send out every Friday. It's completely free. I write every single word in the newsletter. There's no ads. You can go to universetoday.com/newsletter to sign up. Now, I'm going to talk about some really cool reporting about Breakthrough Starshot, but first, I'd like to thank our patrons. Thanks to Abe Kingston, Bear Lake Roofing, Brian Bode, Caradwin, Chuck Hawkins, Commander Baylock, Cy Nielsen, David Veribioff, David Gilton, David Matz, Evan Pro, Greg Feely, Hudson Work, James Clark, Jeremy Madden, Jim Burke, Jordan Young, Josh Schultz, Marcel Switz, Michael Purcell, Modso, Paul Robach, Ren Kaidu, Richard Williams, Sean Sargent, Stephen Fowler-Munley, Team 49, Vlad Chiplin, and Wolfgang Klotz, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So like you, I got very enthusiastic about this idea of Breakthrough Starshot. This is a plan that was announced about a decade ago, where it was funded to about $100 million by the billionaire Yuri Milner, and there was going to be support from a bunch of famous people. There was astronauts involved. There was Stephen Hawking and Avi Loeb and Mark Zuckerberg. And the goal was to develop the infrastructure for an interstellar spacecraft. And it sort of was the best idea at the time, which is that you would use a laser to accelerate a spacecraft to relativistic speeds so that you could travel between stars in a human lifetime and be able to send data home. And, you know, we've reported tons on both the original setup of this, as well as lots of bits and pieces of all of the technology, from the lasers to the solar sails, to the kinds of chips, to communication technologies, and on and on and on. And yet, we haven't seen a lot of official announcements coming from anybody involved with Breakthrough Starshot for years, that there's been this silence. And I was always wondering, like, whatever happened, and thought it would be kind of interesting. Someone should go and look into this at some point. And it turns out somebody did. And that is Sarah Scholes, who is a terrific journalist. I actually interviewed Sarah about 4 years ago for a book that she had done about UFO culture. And so this new article is all about whatever happened to Breakthrough Starshot. And it looks like it just quietly went away. It just got quietly shut down and people moved on to other things. And it looks like they didn't distribute the full $100 million as everybody was expecting, that there was some financing for various projects, but a lot of funding was matched or found through NASA and other places. What I found really interesting in watching this whole thing unfold, as well as reading Sarah's story, is how much this capitalized on this pent-up enthusiasm for an interstellar mission, that somebody was finally considering a practical interstellar mission, and that we were going to see this move forward, that there was all this pent-up demand. And yet there still wasn't enough funding supplied to be able to make this get off the ground and move forward. And here we are, 10 years later. Whatever happened? Some interesting technology were developed. People worked on it for a bit, but kind of nothing. And that's too bad, because you can see how much enthusiasm there is. And so imagine if someone was willing to sort of pick up this mantle and carry it forward and continue funding it and sort of see this through. Maybe that would be a valuable asset for a billionaire to work on. I don't know, just me. But anyway, I just want to direct you to this incredible story. It's over on Scientific American, written by Sarah. Fantastic work. And I think it'll help give you some closure on whatever happened to Breakthrough Starshot. All right, we'll see you next week.